Welcome back to educator.com. For the next lesson, we're going to go over probability of compound events and those events being independent and dependent. So before we go over these events, let's first review over probability. Now, probability is talking about the chances of something happening, right? So what's the probability of picking a card from a deck? Or what's the probability of rolling a 2 if you roll a die? Okay, so probability talks about your chances of something occurring. Now, to find probability, we're looking at a ratio. A ratio is like a fraction, right? It's comparing the top number with the bottom number. So probability is talking about your desired outcome or the outcome that you're looking for over the total possible number of outcomes, or just total for short. So it's desired outcome over the total is a probability. And probability, once you have this, you can leave it as a fraction. You can change it to a decimal. Okay, it's just fraction to decimal. You just divide the top number with the bottom number. Or you can change it to a percent. Okay, so usually probability is left as a fraction. It's the desired outcome over the total. Now, if I have a die, a number cube, okay? We're going to talk about number cubes in our examples later. So a number cube has 6 or different number of dots on each side, right? There's 6 sides. Each side has a different number, 1 through 6. So if I said, what's the probability, what are the chances of rolling a 1? Well, my desired outcome then, so I'm going to say my probability of rolling a 1. And that's how we write it out. Probability of rolling a 1. Then, that's my desired outcome. Well, how many sides has a 1? Only one side, right? So my desired outcome, there's only 1. Over, how many total sides are there? How many total possible outcomes are there? Well, there are 6 sides, so my total is 6. So the probability of rolling a 1 is 1 over 6. Same thing if I said probability of rolling a 3. Well, be careful. This number is not going to be the number on top. How many sides have a 3? Only one side, right? So my desired outcome would be just 1 because there's only one possible side that's going to be a 3. So it's 1 over, how many total sides are there? 6. So the chances of rolling a 1 is the same as the chance of rolling a 3, right? So that's probability. Now, when we talk about 2 events, so each of this is one event, right? You're rolling a 1. This is another event, rolling a 3. Each of those are events. Now, we're talking about when we have 2 events or 2 or more events. Okay, when we have 2 events, when there's 2 things going on, those 2 events can be either independent events or dependent events. And that's what we're talking about now. So independent events is when the outcome of the second event does not depend on the outcome of the first event. Now think about what the word independent means, right? It doesn't depend on it. It's not affected, right, by anyone else, anything else. So the first event happens, the second event happens. They don't affect each other. When you have 2 events that are independent, then we write each of those events as A and B. So it's probability of A, that's the first event, and then the probability of B, that's the second event. Okay, when we have 2 events that are independent, all we have to do is multiply the probability of that first event with the probability of the second event. So let's say I have a bag of marbles. And in this bag, I have 1, 2, 3 red marbles. Say I have 2, 3, 4 blue marbles. And let's say I have 2 green. Now I don't have green, so I'm going to just use black for green. I'll put G for green. So 3 red marbles, 4 blue, and 2 green marbles. I have a bag of marbles. Now, just talking about one event, let's just say, what is the probability of picking a red marble? Okay, that's one event because I'm going to pick up one marble, right? So the probability of picking a red, okay, that red is my desired outcome. That's what I'm asking for. So how many reds do I have? I have 3 reds. So that number, the desired outcome, is going to go on top. 3 over how many total number of marbles do I have? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. And then if you have a fraction, you always have to simplify it, right? So I can simplify this by 3, divide each by 3. So it's going to become 1 over 3. So the probability of picking a red marble is 1/3. Now, that's only when you have one event, right? Now, talking about compound events, 2 events, if I ask for the probability of picking a red and afterwards picking a blue, probability of picking a red, we already found that. That's 1/3, right? So it's going to be probability of picking red times the probability of picking the blue. Now, the only way this is going to be both of these events, picking the red and then picking another marble, the blue, the only way that these 2 events are going to be independent is if after we pick the red marble, right? After this first event, after you pick the first marble, you have to place it back into the bag. Okay, so you're going to pick one out, put it back in, and then pick the second one. Okay, then it'll be independent because then picking this red or picking this one, it won't affect this one. So probability of picking a red marble, we know that's 3 over 9 or 1/3 times probability of picking a blue. So blue is my desired outcome. I have 4 over a total number of 4, 5, 6, 7, 8, 9. So then, and again, after we pick this first event, after we pick the first marble, we put it back in the bag, right? So then now it's just the original number of marbles, the same number of marbles, but when we pick the blue one, we pick the second one. This is 1 times 4 is 4 over 3 times 9 is 27. Now this can't be simplified, so this is our answer. So the probability of picking a red and then after replacing it, picking a blue would be 4 over 27. Okay, so this is independent events. Now, when we have 2 events and the second outcome is affected by the first outcome, then we have dependent events. Okay, so the second event depends on the first event. Okay, so finding the probability of 2 dependent events is a little bit different. Now, same thing here. When we have probability of the first event A and then the probability of the second event B, we're still going to multiply them. It'll be the probability of A times the probability of be after A because, remember, this second event is affected. It depends on the first event, A. So back to the bag of marbles. So again, 3 red, 4 blue, and 2 green marbles. Okay, so same bag of marbles, but now the way it becomes dependent events. I want to find the probability of picking a red, and then my second event will be picking a blue, but the difference is here, after we pick the first marble, right? After we pick the red, find the probability of picking a red. We're not going to put the marble back in the bag. Okay, we're going to take it out and we're going to leave it out. Then the second event, the probability of picking a blue is going to be slightly different because the total number of marbles is different, right? There's less marbles. So that is why these would be dependent events, because the probability of picking a blue is not going to be the same as if we were to place the marble back in. So this will be probability of red times probability of blue, and again, we're not going to replace it back in. So the probability of picking a red, how many reds do I have? My desired outcome is 3, right? So desired outcome goes on top, 3 over total number of marbles is 9. Now you can simplify this to become 1/3, right? So let's say that, let me just change this to 1/3. Now, because this red is no longer there, okay, we took it out. Okay, that's the first event, right? And then for the second event, since this marble was not replaced back in, okay, it's left out, this is going to be different. So then probability of picking a blue, my desired outcome is number of blue. How many blues do I have? 4. And then my total number of marbles is going to be different. It's going to be 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 1 less than the total here. Now this was originally 9 before we simplified, right? So now it's going to be 8. There's 1 less marble in the bag. So now we multiply these numbers, and it's going to be 1 times 4 is 4 over 3 times 8 is 24. Now this can be simplified, right? 4 goes into both numbers. Divide each number by 4. This is 1, and this is 6. So the probability of picking a red and then picking a second marble, blue, without replacing marbles is going to be 1 over 6. Excuse me. Okay, so let's go over some examples. Determine if the 2 events are independent or dependent events. So the first one, rolling a number cube twice. Now remember, for independent or dependent events, we have to have 2 events, at least 2, right? So here, rolling a number cube twice. So the first event would be the first time you roll the number cube. And then the second event is going to be the second time you roll the number cube. So does the second event depend on the outcome of the first event? So meaning, if we roll a number cube, if we roll a die, we get either 1 through 6, right? 1 to 6, a number from 1 to 6. And then if you roll it again the second time, does it change or is it affected? So if I roll a 2 the first time, does that mean I can't roll a 2 the second time? So the first time we roll a number cube, all the numbers, let's say I want to find the probability of picking a 5. how many 5s are there? How many sides on the number cube is a 5? There's only one side, right? So it'll be 1 over 6. That would be the probability of my first rule, right? Then for my second rule, okay, what's the probability of picking a 5? Or picking any number? It's also 1. Do the number of sides change? No. Still the same. So this rule and this rule, my second rule, they don't affect each other. They have nothing to do with each other. So in this case, this would be independent. Okay, and the second one, drawing a card from a deck of cards and without replacing it, drawing another card. Now, there are 52 cards in a deck. So if I pull a number out or take a card, okay, that's my total number of cards is going to be 52. If I don't put it back in, then for my second draw, when I draw my second card, my total is going to be different, so my probability will be different. Okay, because it's always desired outcome over the total. Well, for my second draw, there's less cards in the deck, right? So in this case, this would be dependent, because the first or the second draw depends on the first draw, right? The outcome of the second is affected by the first. So dependent. Picking 2 students in your class to be class representatives. Now, imagine a class, your class, okay? There's, let's say, 30 students in the class. You pick the first student. Now, that student, let's say you're picking the president and vice president, okay, as class representatives. If you pick the first student to be your president, how many students do you have left to pick from when you pick the vice president? Okay, so the total number of students, does it change? It does change, right? Because you already picked one student, and that same person can't be both, right? So then you pick one student to be the president of your class. Then for the vice president, you have one less student to pick from, right? You have 29 students. So this is dependent. This is a dependent, or these two events would be considered dependent events. Okay. Samantha rolls a number cube twice. Find the probability of each pair of events. Okay, so then here, rolling twice, 2 events. This is the first event. This is the second event. So we want to know the probability of rolling a 2, and then probability of rolling a 5 afterwards. So probability of picking a 2. A number cube. So let's say 1 here, and then 2 here, and then say 5 here. Okay. So how many sides? There's 6 total sides. How many sides have 2? Only one side does, right? So my desired outcome is the 2. But how many 2's are there? Only 1. So it's 1 out of a total 6. And then what's the probability for my second roll, for my second event? Probability of rolling a 5. Well, again, there's only one side with a 5, right? So 1 over, still number of sides is the same, 6. So the probability of rolling both of those, I just have to multiply probability of 2 times the probability of 5 occurring. So it's going to be 1 over 6 times 1 over 6. 1 times 1, 6 times 6 is 36. So the probability of rolling a 2 and then rolling a 5 afterwards is 1 over 36. Okay, now this one here, the probability of rolling a number that's not a 3. So probability of not 3. How many, so that's my desired outcome, not 3. Okay, how many numbers are not a 3? Well, we have 6 of them, only 1 is a 3, so the rest aren't, right? So there's 5 sides that are not 3. So that's going to be 5 on the top over, how many do I have total? 6. And then that's my first roll. That's my first event. My second roll is probability of 6, rolling a 6. And again, there's only one side with the 6, so that's 1 over 6. So probability of the first one times the probability of the second one. Probability of that is 5 over 6 times the probability of the second one, 1 over 6. 5 times 1 is 5 over 36. That can't be simplified, so that's my answer. Okay, here we have a spinner that we're going to use to find the probability of each. So the first one, I only have one event, right? Only one spin. And I'm looking for the probability of rolling a black. Now, there are no blacks. It's red, orange, yellow, green, blue, purple, light purple, and then another orange. So, probability of rolling a black, well, my desired outcome is black. Do I have any black? Nope. So, 0 on top over how many total do I have? 1, 2, 3, 4, 5, 6, 7, 8 over 8. So this 0 over 8 is always 0. If I have 0 on top, that's going to make the whole thing 0. So here, there is no probability of picking a black, right? That's what the 0 means. For the second one, we want to know the probability of picking or spinning a red. And then, if we do a second spin, because there's 2 events, right? So first spin lands on red, second spin lands on green. So probability of red. How many sections of red do I have? I only have 1, right? So 1 over total number of sections, 8. What about probability of green? Now this would be considered an independent events, right? Because if I spin the first time, I land on red, that's not going to affect what my second spin is going to land on, right? So these would be independent. The probability of green is 1 out of 8. So then I multiply them together. So 1 over 8 times 1 over 8. 1 times 1 is 1. 8 times 8 is 64. So the probability of landing on red and then spinning again, landing on green is 1 over 64. The next one, the probability of landing on any color that's not yellow, and then for the second spin, landing on blue. So probability of not yellow. How many are not yellow? There's 8. There's only 1 yellow, so 7 are not yellow. 7 over 8. And then the probability of blue. There's 1 blue, so 1 over 8. We're going to multiply them together. 7 over 8 times 1 over 8 is 7 over 64. Now, if you notice these two numbers, the chances of this happening is greater than the chances of this happening, right? Because here, the chances of landing, the spinner landing on a color that's not yellow is actually pretty high, 7/8. That's pretty high because there's so many spaces that are not yellow, right? So if this fraction is greater than this fraction, that means the probability of this or this happening is greater than the chances of that happening, right? Okay, and for our fourth example, we have a bag of marbles. I'll draw my bag of marbles. I have 5 red marbles. 1, 2, 3, 4, 5. I have 4 blue. 1, 2, 3, 4. And then I have 6 green. Now I don't have green color, so I'm going to do black G for green. 1, 2, 3, 4, 5, 6. Okay, we're going to find the probability for each when the first marble is not replaced back in the bag. Okay, so then here we have 2 events, right? So 2 things are happening. We're going to pick 2 marbles. After we pick the first marble, we're not going to put it back in the bag. Okay, it's not going to be replaced back in. So we pick one, then that one stays out of the bag. And then we're going to pick our second marble. Okay, so that's my 2 events. And remember, the second event, because after we pick the first marble, we're not going to replace it back in, so that's going to affect the probability of that second marble, right? So this would be, or both of these would be considered dependent events, because the second one is affected by that first event. So let's first talk about this event, the probability of picking a green. That's our first pick, green. So probability, we look at the desired outcome over the total possible number of outcomes. How many green marbles do I have? So I have 1, 2, 3, 4, 5, 6. 6 is going to be my top number over how many marbles do I have total in all? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's going to go right there. So the probability of picking a green is 6/15. Now, it's still a fraction, so I still have to simplify it, right? What number goes into both 6 and 15? They share a factor of 3. So this is going to be 2/5. The probability of picking a green is 2/5. Well then, now I have to pick my second marble, and that's going to be red. Now, because that first marble was not replaced back in the bag, this marble, one of the green, is now gone, right? It's no longer in there. So probability of picking the red. How many reds do I have? I have 5 red marbles, 5 on top, over how many marbles do I have now? Well, after that one's gone, I have 14 left, right? So it was 15 and then minus the one that we already picked. So now it's 5/14. Okay, so the probability, and now this fraction I can't simplify, right? So that's the probability of picking the red. So now I can, to find the probability of both happening, I take this one and I take this one and I multiply together. So it'll be probability of the green times the probability of picking the red. And this is dependent, so it's the red after green. So 2/5 times 5/14. 2 times 5 is 10. 5 times 14 14 times 5, we do this, right? That's 20. 5 times 1 plus the 2 is 70. Now, fraction, so I have to simplify it. What number goes into both, top and bottom? 10, so I divide by 10 for each. I get 1 over 7 as my answer. So the probability of picking a green, and then afterwards, without replacing it back in, picking a red marble is 1 over 7. Okay, let me write this for this second problem. Now we want to find the probability of picking a blue, and then afterwards, without replacing it back in, pick another blue. So again, 2 dependent events. So probability of picking the first blue, the first event. What's my desired outcome? How many how many blue marbles do I have here in the bag? I have 4 blue over a total of 15 marbles. So the probability of picking a blue marble is 4 over 15. I can't simplify it, so that's the probability. And then for my second pick, because again, it's not being replaced in the bag, this one is no longer in the bag. So I have 1 less marble. So for my second pick, I want to look at how many blue marbles I have left. I have 3 left. I had 4, but 1's gone. So now I have 3. Over, and then I don't have 15 anymore. I have 14 now. So probability of picking the first blue was 4 out of 15. Because I had all my blue, just 4 of them, out of a total of 15 marbles. For my second pick, I'm also wanting to pick another blue one. I only have 3 left because the first one wasn't replaced back in, out of a total of 14 marbles left. So now I'm going to take the first event and then multiply it to the probability of the second event happening. So it's 4 over 15 times 3 over 14. 4 times 3 is 12 over 15 times 14. Okay, you're going to multiply it. This is 20. That's 4 times 1 is 4, plus 2 is 6. Okay, I leave the space alone. 1 times 5 is 5. 1 times 1, 1. I'm going to add them down. 0. This is 11. This is 2. So 210. Okay, now I know I can simplify this fraction because this number is an even number and this number is an even number. So let's divide each of these by 2. Oops. So 12 divided by 2 is 6 over this. If I take the 200 and I divide it by 2, I get 100. So this divided by 2 is 100. This divided by 2 is 5. So if I divide the whole thing, it'll be 105. Okay. Now, it looks like 6 over 105. I also have another factor. So I can divide this again by, I know 3 goes into that one, and 3 also goes into this one. So 6 divided by 3 is, write it down here, 2 over 105 divided by 3. Okay, let me show you that one. So 3 goes into 10 3 times. That gives you 9. Subtract it. I get 1 left over. Bring down the 5. 3 goes into 15. 5 times. That gives you 15. We subtract it. I have no remainders. So my answer is 35. Okay, can I simplify this further? Okay, no, I can't because this is not an even number, so this is my answer. So again, finding the probability of two events, you have to find the probability of each event occurring, and then you're going to multiply them together, whether it's independent or dependent events. And that's it for this lesson. Thank you for watching educator.com.